Hey guys, welcome back to the channel, the DevSecOps experience. Today I'm back on the same topic, Shift-Left. I want to touch on some topics I didn't talk about last time. That was more high level, talking about where it came from and the strategy, and I'll cover a little bit of that again just to bring back the context, but then I want to talk about a few other ideas, and I'll provide also an architecture diagram to talk about some execution of those ideas. So yeah, what's all the hype, part two. All right, I'm back. All right, so just going over stuff from last time. The idea behind shift left is to take the things that are in the production environment, all the vulnerabilities, and try to get to them early before they ever reach into production. So before you deploy to production, during the pull request, local development, during the feature design, trying to capture vulnerabilities and threats and risks early on and mitigating them, or removing those threats and etc. before they ever get to production. That's the idea. And also in the next slide, as you could see, is also the idea of what it means organizationally. So the idea is that the security team doesn't have to be patching all the vulnerabilities themselves. Instead, by shifting left, you're enabling the developers, the DevOps teams, a little bit of the analysts, but mostly developers and DevOps teams to take care of the vulnerability management themselves, and the security team is just the enabler. By enabling those tools, procuring the right tools, um, and and effectively forcing developers to use them during the different parts of the life cycle, what's called the software development life cycle. Now, sometimes this is difficult to do, and this is where I want to get into today's topic. So, the way this works traditionally is let's say in the case of pull requests, you get some sort of tool vendor, or you do it yourself as well. You could do it through GitHub Actions and things like that. What are called required CI checks. That's how it is in GitHub. At least GitLab is similar. And let's say in this example, there's a vulnerability to pull request, and now you've blocked the developer from merging it. Until they've patched the vulnerability, they can't merge. And when companies take that approach, it's really effective because now patching vulnerabilities is front and center. If you don't do it, you can't merge your PR. Now, sometimes the downside of this is it does cause friction. It lends itself to more friction because in certain cases, let's say the tool you're using, whether it's Snyk or some other third-party tool to do the vulnerability scanning, might actually have a bug in it. Maybe it's a false positive. Maybe it didn't run right. And now the developer says, hey, my PR can't merge. It's urgent. And your security tool is messing it up. And they don't really care about security. They're saying, I need my code to ship. I'm not touching any vulnerable packages. I'm not introducing any new vulnerabilities. Why is this happening? Fix it now. And then all of a sudden you've created friction between the teams. That's one example. Another example is projects that are maybe just the dev. Maybe it's just the dev environment, and now we're doing blocking because vulnerabilities affect the dev environment. And similarly, the pull request is blocked, and it's really blocking the developer's ability to iterate fast. And if you think about it, there's a lot of things happening in the modern enterprise today. One of them is this idea of shift left and managing vulnerabilities at scale, but the other is agile and helping developers move at a higher velocity, because in today's like competitive environment and in business, the teams, the companies that move fastest have a major advantage, and so there's an important emphasis on agile development. And so those two things can clash, and you still want to be able to do it, but you have to take into account the developers and the sentiment. And so that's where we get into this idea of asynchronous shift left. So it's another way to approach it, and in this case, we want to find alternative ways. And when I say asynchronous, the idea is it happens in parallel, not as a blocker in each step of the software development lifecycle. Instead, it's a way to bring things to the developer's attention without needing to actually mess with the software development lifecycle. That doesn't mean we shouldn't do it, and I'll talk about that after I show this architectural walkthrough. But it's another approach to shift left. So here in this case, we have the architecture of what this could look like. So the idea being is instead of running integration at the pull requests or before you go to production, or at the different steps. Here we would have just a weekly cron. This could be daily, but you don't really want it more than weekly. It could theoretically be monthly, etc. But the idea is working based on crons, something that works on a scheduled basis. So let's say every Monday at 9 a.m. And all the code effectively runs here, but it pulls in data and tools from different places to be able to execute what it's meant to do. So what's happening here? So the idea is we have a source of vulnerability data. This could be a third-party tool. It could be at the same time running open source tools, container scanning, static code analysis. It could be looking at all sorts of different third-party tools you have, open source tools you're using. It could either pull them in from a database that already exists or run those tools in during the time of the cron. Up to you, but the idea is get good trusted data about vulnerabilities. Okay, next we need to know who's responsible for patching those vulnerabilities, because it's nice to have a list of these 100 vulnerabilities, let's say, that are affecting our organization, but you don't want to be chasing down who's going to fix what, because then you're doing more time, instead of running your code and executing your code, you're doing more time asking people, hey, do you know who owns this? Do you know who owns this? So this is where it's really important to have some sort of system for ownership metadata. So you need to have a mapping of relevant teams or owners to either code or to data, or to assets. So for code, there's a lot of different ways to go about this. You can create a static mapping, have like a JSON mapping, repositories, let's say, to teams, or directories to teams if you have mono repos. For assets in the cloud, things like that, you could use tagging, so automated tagging, so that when a team, you're provisioning something in a certain team's account, or if it's in a shared account, if it's a certain team provisioning it, automatically it will tag it with the teams, with some sort of indicator which team owns those resources. And this is really important because it gives a lot of control and a lot of power to security teams, but not only security teams. It's great for FinOps. It's great for all sorts of initiatives at a company when you know who owns what. But it's truly crucial for security, because if you don't know who owns what, this is hard to get off the ground. So when you're doing this, if you're taking this sort of initiative at your company, it's really important to focus on, do we have ownership metadata? If not, okay, let's see what we can do to get one started. And the simplest, if it's just Git based, is first start with the Git repositories. Who owns the Git repositories? And you could store this data in all sorts of places. You could store it in a sort of database, or a DynamoDB or S3, or you could even store it in GitHub itself. GitHub actually has a really cool new feature called custom properties on the repo itself. So you can define custom properties on the organization, and then fill those values on every repo. So you could set a new custom property called owner or team, and then you could have that be filled out for every repo. And then as part of the vulnerability data, if you know this repo has these vulnerabilities, you can then get that data. And then you could map that additionally to other things. Once you know the team, you can know, well, who manages that team? And then if I get to the next part, which Slack channel, if it's Slack based or Teams based or things like that, which Slack channel is the appropriate Slack channel to talk with that team or to talk with that person? And so if we go back step 1, step 2, so first we get the vulnerability data. Second, we take that data and we map it to the relevant owners. We group it. Then we integrate a Slack application, and Slack is the most popular messaging tool at companies today, but you could take the Teams equivalent, effectively some way to have an API to write to the messaging platform. And then you take the contextual data. So for any given team, you can now have a group listing of all the vulnerabilities affecting them, and by criticality, criticals, highs, etc. You could also provide them additional info that might be useful, so actionable data. So if, let's say, they're using package version 1.x, which is vulnerable, and if they patch to 1.y, it'll be fixed, you could put that in the data. You could say package 1.x high vulnerability, patch to 1.y. The nice thing about the fact that we're using Slack is you can make a very readable message. You don't need to make it too long. You don't want to make it too long, too verbose, but you want to keep it short and concise, but it's nice to be human readable and not just have sort of spreadsheets. So this gives them something to work with. And then what's nice here is now the developers have a frictionless shift left. So they're getting it directly into their, we're telling the developers what they need to patch, not us, the security team, go and patch it for them, but they also do it in a way where we're not intruding into the software development lifecycle through blocking. And so it's another approach. It doesn't have to conflict. It doesn't mean one or the other, but it's another powerful approach to be able to give developers, to empower them to own their own security status. At previous companies I've worked at, we've done this, and then we've even built on top of this where we have those weekly crons, and we would store that data in a S3 or in a backend, and then make a little very simple UI so that teams could even have a UI where they can go and see their vulnerability status that's continuously updated, or daily or weekly or whatever makes the most sense. So this is a really powerful tool that I recommend for many companies to make use of. Now, if we go to the next one, I just want to sort of cover asynchronous versus synchronous. So synchronous means it's step by step. That's the software development lifecycle, and we're in that software development lifecycle. We want to stick new steps. Excuse the spelling mistake there. I see that now. I'm not going to redo the video for that. But the idea is we're going to take the literal step by step. So if we have a 4-step process for the software development lifecycle, we're going to stick a step in the middle of that, which is security. And in this case, that could be passive or active, meaning it could give developers visibility, or it could be active, meaning it could actually be blocking. And it says, nope, you didn't pass my step. You need to fix it before you can go on. So that's the idea of synchronous. And asynchronous is saying, okay, let's put the software development lifecycle to the side. How do we just get this information to the developers in a clean, efficient way that empowers them to patch their vulnerabilities? Because the thing about a software development lifecycle is, if we look at the synchronous one, you think about it, every pull request is generally some developer is working on it, not the whole team. And so that means that developer is going to be notified about vulnerabilities he's introducing during the pull request. What's nice about the asynchronous method is you could write it to the team channel about all of the team's vulnerabilities. And so that's why both are good, because asynchronous allows you to sort of give a general status update and general, like, here's what your team needs to do in a timely manner, whereas synchronous is more targeted. It's targeted as well toward the team, but oftentimes it feels like it's more toward the actual individual developer. So this allows you to cover both sides, and that's why I'm saying both are better than one, but more emphasis depends on the company and the culture and the priorities. Also misspelling, sorry about that. You have to take all those things into account, because you really want to balance the amount of friction with the amount of efficacy, and really ensure that you're getting the most out of your developers and you really take care of that relationship. And so investing a lot in the frictionless makes it more rewarding when you do introduce some friction, because if they're already in a good state and they have a good cadence for vulnerability management, it's easier to introduce those friction steps, because they are not as they're not as full of friction if you start with those. If you start with those and they have a lot of vulnerabilities, well, then they're just blocked all the time and they're not used to how to patch and this and that. Whereas if you start with the frictionless, it really empowers them to know what they're doing, get used to it, and then you could slowly add more and more and more and build a really robust security culture at your company. And that's really it. I didn't want to cover too much today, but I wanted to introduce this idea of the asynchronous shift-left. So thanks for coming to the video. I'm going to improve the video quality next time. Still working on that. This is just a little side project. So let me know if you guys have any particular tools. I'm happy to demo. For now, I'm keeping it high level and abstract. Better, and looking forward to seeing you guys next time.